I had another example of a problem that I believe you think is basic and you worked on. So this is a Heilbronn problem. So maybe you can describe it also.
It's a beautiful problem, and Rod, one of the Fields medalists and one of the greatest mathematicians of the last century, worked a lot on it. So the problem I just will formulate first for triangle, and then later a little bit more general, because in the general case nothing practically is known. For the triangle something is known. So the problem is the following, that you have a unit square and the devil puts down and points so that you consider all of the triangles.
So all the triangles at this endpoint.
Endpoints, which is, we call it then the number of triangles n choose 2, which is approximately, let's say, n to the 3.
N choose 3, yeah. N to the
n cube. And then you actually choose the triangle which has a smallest area. And then Heilbronn conjecture was that the devil cannot do a very good job. Maybe the smallest area always will be less than 1 over n square. Regardless how the adversary puts down the endpoints, it will be always a tiny, and tiny in that case means 1 over n square. And that was for the triangle, and then they started to prove it step by step, improve the bounds, like Ross was the first one who proved that, okay, not 1 over n square, but always there is a triangle area 1 over n times log n in the denominator. Then Wolfgang Schmidt, again a giant in mathematics. You see the Wolfgang Schmidt work and both Ross on a very important problems. Nevertheless, they consider this one an important one too, though many might disagree. So then, with beautiful proof what Wolfgang Schmidt gave, stated that there is always a triangle, that the area is at most 1 over n times log n. N times log n is in the denominator. Yeah. And then he took a completely different approach of Ross. According to him, he worked 5 years on it, and then he proved that there is always a triangle of area 1 over n to the 1 plus, let's say, 1 over 100. But still, 1 plus 1 over 100 is far from 2. Yeah. So that is now the art of the state of the art, at least as far as this problem is concerned.
Well, you refuted...
Yes, but yes, with Miklós Ajta and János Komlós, we refuted the conjecture which is called Heilbronn conjecture, stated then 1 over n square is the right bound, and then there are random construction and deterministic construction. Actually, the nicest is due to Paul Erdős, where there is the endpoint, so that the smallest area triangle is of area 1 over n square. But then we used the so-called pseudo-random method, which at that time was not called pseudo-random method, and we disproved. Then we actually semi-randomly, whatever it means, constructed endpoints where the smallest area triangle had an area log n over n square, but still n square, so nobody knows whether 1 over n to the 2 minus epsilon is true or not. That is a major open problems, because already Ross solution required a lot of mathematics, Fourier analysis, functional analysis, and then that kind of stuff. It was striking how he came to that idea. But now let's see that you are interested in the following thing, that you consider 4 points. So if you consider 4 points, what could it be then? A triangle, 1 point inside, or a foregone? Yeah. Yes? And now the same question. You are looking for the smallest area. It is small, well, of course, it's always smaller than 1 over n. It's easy to prove, right? It's not even at most high school exercise, but actually a very good 8th grade students in elementary school could solve it. But nothing known, then it is just slightly less. Little meaning that less than 1/n is not known. That would be the first step. And in the another direction, which is unbelievably interesting, but it's a great problem, is that there is always a triangle of area 1/n which contains k points.
This is a result of that?
No, that is, of course, that would be much stronger than the previous one, because, yes, that is a conjecture that even this is true. Fix any k, and if n is large, then you always, and then you put down n points, then you always will find a triangle containing k points.
With area 1/n.
Those area, of course, 1/n. And what would be the expected number of the points? 1. Yes, because you have n points, the area is 1/n, then you expect in average at least 1 point. Instead of that, you have k points. It's very far from the expectation, but that is true. Almost sure must be true. But the proof would really now require so-called real mathematics. I'm sure then you, within the usual combinatorial arguments, whatever it means exactly, you cannot solve this problem. But there is another problem which is equally interesting. Then regardless how you put down n points, there will be always a triangle of area now k/n, which is empty.
Now you want a lower bound, you want to say that there is a large, it's an opposite game.
The opposite game, exactly, so the opposite, so there are discrepancies in both ways. Too many points, or too big triangle, or just too big empty triangle.
These problems are comparable to the sunflower problem?
Yes, they are. That's comparable. We don't know, yes. And in beauty too. I mean, if you read the Ross solution for that, it's just completely out of volume.
Before you know the solution, whether it's clear that it's so.
Well, this most probably is clear, then it is a very difficult problem.
Why did Heilbronn ask it?
I don't know. There is a story that then he looked out the window and the soldiers were marching, and then I don't know what is the connection between them and that. So it's just.
So that's how basic problems come about.
Right. So if you don't have an army, most probably then some of the basic problems will not be asked.
Steiner triple system. Yes. I think he was watching out the window and looking at the schoolgirls that were passing.
Right, yes, it was good. Then they were girls maybe, yes, not boys. We don't know, of course.